Okay, here we're doing a few of the worksheets from week 6, a few of the problems. I'm not doing entire worksheets. A few of the problems from week 6. So here's number 2 from the piecewise defined functions worksheet. We want to graph this function here. Okay, so we do this one piece at a time. Remember, f of x is just a fancy way of saying y. So the first thing I want to graph is y equals -4. So I'll write that over here on the side. Y equals -4. What is that? That's a horizontal line. So I'm going to lightly sketch that in. Y equals -4. That's down here. Y equals -4. But I don't want the whole thing. That's why I didn't make it really dark. I only want the section of it when x is less than -2. So here's when x is -2. Here's where I start. And I want the left side over here, less than -2. Don't think up and down, think left and right. So x equals -2 and left. I want to keep this chunk of that first function, y equals -4. And because I have the equal to here, I'm going to end it with a solid dot right here at -2. That's x equals -2, y equals -4. Okay, I'm 1/3 of the way done. Next, I'm going to graph the entire line, y equals x minus 2. But I'm going to put it in really lightly. Y equals -2 has a y-intercept at -2. 0, -2. Has a slope of 1, so if I go over 1, up 1, there's another point. Now, it looks like this dotted line I've just drawn is actually going to hit that solid dot. Let's check that and see if that's true. So I'm going to use this smaller x value, the one these two share, -2. And I know I'm not supposed to use it here, but I'm going to plug it in anyways because that'll show me where my open circle is supposed to be. So plug this smaller x value in for x. -2 minus 2 is -4. So if I had an equal to here, I would have a solid dot at -2, -4. Because I don't have an equal to, I would get an open circle. But I've already got a solid dot in that spot. Who wins? The solid dot wins. So I get, really, there's an open circle there and a solid dot in the same place. The dot wins. That's my starting point for this line. I'm going to go all the way up until x equals 2. Okay, so I'm going to keep going until x equals 2. Now, this is a rough sketch of the line, so I should really check and see exactly where it's going to hit. So we plug in this value. 2 minus 2 is 0. That's where I'll stop. And that's an open circle. Again, open circle because there's no equal to here. This side had an open circle, but that open circle happened to land on an old solid dot, and the solid dot wins. Okay, so this chunk right here is y equals x minus 2 between -2 and 2. Now finally I graph y equals -2x plus 4. And I only keep the part when x is greater than or equal to 2. Okay, and you should be really good at graphing lines by now. If you're having trouble graphing this, you need to go back and review graphing lines. This line has a y-intercept at 4. 1, 2, 3, 4. Just putting it in lightly. That's not going to be part of my final picture. But I'm just using that to graph. This is just a guide. Then my slope is -2. So over 1, down 2. Here would be another point. At the point, oh, that looks like 1, 2. Okay, and I would dot him in very lightly. So this dotted line here, you probably can barely see it, but it lives right here. I want to check and see where his solid dot's going to be. So I take this endpoint and plug it in. All these numbers eventually get plugged in. So plug in the 2. Negative 2 times 2 is negative 4, plus 4 is 0. Hey, that's where this other open circle already lived. So that will be the solid dot beginning of this one, and I keep everything x greater than 2. So I keep all of this. In this case, again, it won't always happen, but in this case, we got a solid dot that landed right on an open circle. The solid dot wins. So here's my final graph. Just that there. Everything else that was dotted in, if I weren't writing in pen, I would erase that. But that's not part of the final answer. Okay, so that's a piecewise example. Here is a completing the square example. This is number 8 from the completing the square worksheet. Let me zoom a little better here. Okay, when we're completing the square, first thing we do is if there's a number here, a leading coefficient in front of our squared term, we divide through by it. In this case, it's 1, nothing to do. Next step, get the constant to the other side. So k squared minus 12k plus blank equals negative 23 plus blank. I always write a plus blank because I know I'm going to be putting something on both sides. What do I put in? I take half of this middle number. So I'll make a little note here. Half of 12 is 6. That's not what goes in the blank, but I'm going to use him later. Later. He comes back. What goes in the blank is 6 squared, which is 36. Okay. On the left side, this is a perfect square trinomial, and it's going to factor. Parentheses with the square. Don't forget the square. Most common mistake made right here. Don't forget that square. Whatever your variable is. Whatever that sign is. If it's a plus, you put a plus. If it's a minus, put a minus. And then this guy here that we had before we squared it. Not the 36, the 6. Equals. Then on the other side, that's just arithmetic. Negative 23 plus 36, I think, is 13. We're almost done. Now we use the square root property, which means we can take the square root of both sides, as long as we put a plus or minus on this right side. Square root of stuff squared, that square root and square just cancel each other out. On the left side, I get x minus 6. On the right side, I get plus or minus root 13. If I could do square root of 13 and get an integer, I would just do it. But I can't. It's an irrational number, so I just leave it. It's perfectly fine like that. Nothing wrong with that number. He's perfectly fine. Last step, I want to get the 6 to the other side. Some people want to write it over here, but it looks weird. We like to put it in front. We want to say k then is 6 plus or minus square root of 13. And that's it. That's it on that one. Okay, a more complicated example. This one's going to be awful. It's going to have a lot of fractions. We're just going to deal with the fractions. We're okay with that. We don't hate fractions. Okay, this is number 2 from the completing the square worksheet. First thing we're going to do is divide by this leading coefficient. Divide everybody by 2. I know you're tempted to get your calculators out and throw some decimals in here. Decimals are not your friends. We're just going to deal with the fractions. Those 2's cancel, and I get x squared minus 5 halves x plus 67 over 2 equals 0 divided by anything is 0. Okay. Next, we move the constant to the other side. X squared minus 5 halves x plus blank is negative 67 over 2 plus blank. Okay, our next step is take half of this linear term. Okay, so let's think about this for a minute. We want half of 5 halves. Half of means times. So that's 1/2 times 5 halves. Anytime you see the word of in a math class, that means times. So just multiply the fractions here. Multiply across the top and across the bottom. 5/4. That's not what goes in the blank though. He comes back later. I will use him later. Now I take that guy and square him. How do you square a fraction? You square the top and square the bottom. So 5 squared is 25, 4 squared is 16. That's what's going to go in the blank. So we get x squared minus 5 halves x plus 25 over 16 equals negative 67 over 2 plus 25 over 16. Make sure you add that to both sides. Left side's easy. The left side's a piece of cake. Don't stress about the left side. Put your parentheses, squared, put your variable, put that symbol. If it's plus, put a plus. If it's a minus, put a minus. And then after that minus, that guy you had up there, before you squared it, half that middle number. It's always like that. Right side's going to be a little worse. We're going to have to get a common denominator here and add these fractions together. So let's do some side work over here on the side. So I want negative 67 over what? 2 plus 25 over 16. I need a common denominator, which is 16. The second fraction's good. He's already got 16. The first one, I'm going to have to multiply top and bottom by 8. So I'm going to use my calculator really quick. 67 times 8, 536. Okay, that's just getting a common denominator. I need a common denominator of 16. I multiply top and bottom here by 8. Now I've got a common denominator. I can add the numerators, so just negative 536 plus 25. I can get my calculator out again. 511. So this is negative 511 over 16. So that's this side over here. Negative 511 over 16. We're actually almost done. Now, we've got junk squared equals a number. To solve that, we use the square root property. We take the square root of both sides. Don't forget the plus or minus on the right. On the left side, square root of junk squared. That square and square root cancel out. We just get x minus 5/4. On the right, I've got square root. I've got a few things going on here. Square root of a negative. Let's put our plus or minus. Square root of a negative is going to give me an I. Remember, square root of negative 1 is I. Square root of 511 I can't do anything with. So that's going to come along for the ride. But 16, I can take his square root. So I get a root 511. I can take square root of 16. That's 4. Finally, one last step. I can move this 5/4 over to the other side. And there are my two answers. Every quadratic has two answers. These happen to be complex solutions. 5/4 plus or minus root 511 over 4 times I. Okay, one more example. We'll do a quadratic formula example from that worksheet. This is number 10 from the quadratic worksheet. We want to solve this equation using quadratic formula. To use quadratic formula, you must be in standard form. Ax squared plus bx plus c equals 0. You have to have a 0 over here on this side, so we have to move that 2 over and get x squared plus 2x minus 3 equals 0. Subtracted the 2 over. Okay, now we're going to use quadratic formula because that's what the direction said to. You may notice that this actually factors, and we could just solve it by factoring, which would be much easier. And if you want to, try that. Solve this by factoring. You'll see you get the same thing we get from quadratic formula. Okay, so first we need to identify A, B, and C. A is your leading coefficient. A, B, and C are numbers. Don't put x's here. B is 2. C is -3. Then x equals the opposite of b, plus or minus square root b squared minus 4ac all over 2a. So x equals opposite of b plus or minus square root 2 squared, b squared will be 4, minus 4 times a was 1, c was -3, all over twice, a was 1. Okay, now order of operations inside here. I have to do -4 times 1, -4, times -3, that would be plus 12 right there. So I'll get -2 plus or minus square root of 4 plus 12 all over 2 times 1 is 2. Four plus 12 is 16. Square root of 16 is 4, so I get -2 plus or minus 4 over 2. Now, whenever possible, whenever you get nice pretty answers and you can simplify them, you should. So that's -2 plus 4 over 2, which is 2 over 2, or 1. And -2 minus 4 over 2, which is -6 over 2, or -3. Hey, for fun, we got the time here. Let's solve this by factoring, see if we get the same thing. Okay, so I'm going to squeeze that in over here. We get x squared minus 2x minus 3 equals 0. That factors. Remember, if you're going to factor, you better have a 0 on one side. That factors x plus 3, x minus 1. Let's check it. X squared minus x plus 3x minus 1x plus 3x is 2x minus 3. If you can't check whether you factored that quickly, you're not good enough at factoring. Go practice factoring. Okay, now I factored. I set each factor equal to 0. Solve each one. Hey, look, x is -3 and x is 1. Same answers we got from quadratic formula. It is always nice when math is consistent. Okay, that's the end of that video.